Download this code from codegive.com, link in the description below. Certainly. The problem largest color value in a directed graph, LeetCode 1857, involves finding the maximum color value that can be achieved in a directed graph where nodes represent colors. Each node can have one of several colors, and you need to consider the directed edges between nodes to determine the maximum color value that can be achieved through valid paths. Problem statement. You are given a directed graph with n nodes and m edges, where each node is colored with a color represented by an integer. You need to find the largest color value that can be achieved by traversing the graph. Key points. 1. Graph representation. The graph is represented using an adjacency list. 2. Color count. You need to count the occurrences of colors along the paths in the graph. 3. Topological sorting. Since the graph is directed, we can use topological sorting to ensure we process nodes in the correct order. Approach. 1. Build the graph. Create an adjacency list from the edges given. 2. Topological sort. Use Kahn's algorithm or depth-first search, DFS, to perform topological sorting of the graph. 3. Count colors. Traverse the nodes in topological order and maintain a count of colors for each node. 4. Determine the largest color value. During the traversal, keep track of the maximum color value encountered. Code example. Here's a Python implementation of the approach described above. Python. From collections import default dict, def largest color value, colors, edges. N equals len, colors. Step 1, build the graph and in degree count. Graph equals default dict, list. In underscore degree equals 0 asterisk n. For u, v in edges. Graph u dot append, v. In underscore degree v plus equals 1. Step 2, topological sort using Kahn's algorithm. Q equals dic. Initialize the queue with nodes having 0 in degree. For I in range, n. If in underscore degree I equals 0. Q dot append, I. Step 3, store color counts. Color underscore count equals 0 asterisk 26 for underscore in range, n, assuming colors are A to Z. Initialize the color count for each node. For I in range, n. Color underscore count I ord, colors I, ord, a, plus equals 1. Process nodes in topological order. While q. Node equals q dot pop left. For neighbor in graph node. Update color counts for the neighbor. For C in range, 26. Color underscore count neighbor C equals max, color underscore count neighbor C, color underscore count node C. Decrease the in degree and add to Q if it becomes 0. In underscore degree neighbor dash equals 1. If in underscore degree neighbor equals 0. Q dot append, neighbor. Step 4, find the maximum color value. Max underscore color underscore value equals 0. For I in range, n. Max underscore color underscore value equals max, max underscore color underscore value, max, color underscore count I. Return max underscore color underscore value. Example usage. Colors equals abaca. Edges equals 0, 1, 0, 2, 1, 2, 2, 3, 3, 4. Result equals largest color value, colors, edges. Print, result, output, 3, the color can be achieved with max count. Explanation of the code. 1. Graph construction. We create an adjacency list and an in-degree list based on the edges. 2. Color count initialization. We initialize the color counts for each node based on their initial colors. 3. Topological sorting. We utilize a queue to process nodes with 0 in degree and update their neighbors' color counts. 4. Final calculation. After processing all nodes, we find the maximum color value that can be achieved. Complexity. Time complexity, O, n plus m, where n is the number of nodes and m is the number of edges, as we go through each node and edge once. Space complexity, O, n plus m, for storing the graph and the color counts. This tutorial should give you a solid understanding of how to tackle the largest color value in a directed graph problem using Python.